All right. Hi, everybody. I said I would do a detailed write-up of this problem from tonight's reading, and I've got it sort of worked out, and it's a little different than how I approached it in class. I can follow up if upon request if people want to go from where I was in class and and how to approach that way. But I am going to use a slightly different approach here. Um, Says the number of users on a social networking site was 45,000 in February when they officially went public and grew to 60,000 by October. If the site is growing exponentially and growth continues at the same rate, how many users should they expect 2 years after they go public? So the first thing to note is that by the time we get to October, we've gone through 8 cycles of growth. So if we write an equation in terms of per month growth, I think, which is a good idea because that's what we have here, then we can then say, all right, 2 years is 24 months. So we can solve for n equals 24. So the way I'm going to write this is that this 45 right here, that is the initial value, sort of the starting value. And according to the reading, that would also be P sub 0. And that's kind of all we have. So using the general setup from the formula, P sub n equals P sub 0 times 1 plus r to the power of n. We don't know r. We do know P sub 0, and we have one time where we know what the answer is if n is 8, we know that this works out to be 60. So I'm going to start by saying, in general, the amount after n months is going to be starting with 45,000, and I'm going to keep that just as 45 because that will make it so our answer is already in thousands. And then this 1 plus r, we still don't know what r is, and we know that's to the power of n. But we have one example. We know that this value is 60 if that value is 8. By the way, if I'm going too fast, this is a video, so you can pause it. You can slow down and reread the question, spend a little more time with that table if you want. So feel free to pause if you want. Subbing that in, I'm going to rewrite this equation as 60 equals 45 times 1 plus r to the 8th power. Now to solve this, basically we want to figure out what r is. So I'm going to start by dividing by 45. This is a multiplication of 45, so a division of 45 will get you there. And this is what we did in class. It turns out that, I'll double check, I did it in my head, but I'm pretty sure 60 divided by 45 is 1.33333. Yeah. So I'm just going to call that. In fact, why don't I use this as an opportunity to say rounding to at least 4 decimal places as we work through this unit. I'm going to call that 1.3333. And now that is equal to 1 plus r to the 8th power. And this is the question I think that was coming up in class. First of all, we saw that number 1.333. So that dividing 60 by 45 tells us that there's been a 33% increase over those 8 months, but that's been split into 8 increments. And we also talked about in class, you might be inclined to divide by 8, but because it's exponential growth, the change isn't the same month to month to month. It's a greater and greater and greater growth. So this is what they were trying to tell you in the setup, is at this point, just like when we have a square, we take the square root to solve it. You're taking the 8th root, right? Which is really saying there's going to be some number times itself, 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 times itself. I think that was 8. That will give you 1.33. And what is that number? And it turns out that you need to figure out where that root key is. So everyone has their own calculator, and the design above will say that. In my case, I have to say, I think I have to type in 8 first. Yeah, so in my calculator, see if this shows that there's this a root key in blue right there that just has an empty square, kind of saying any root. And by entering 8 first, you're saying, I'm looking for the 8th root, or 8 multiplications of this number will give me the 1.33. 1.3333. And this is what I get. So my answer to this was I got 1.0366, again, rounded to 4 decimal places, equals 1 plus R. And if I subtract, actually, I can kind of stop right here because that's the number I need for my equation ultimately anyway. But if I wanted to just say, well, what rate is that? You could subtract 1 from either side. And that basically means that this is growing at 3.66%. We've already talked about decimals to percent. So multiplying by 100 will get you there. So that means is like per 1 month, this is growing by about 3.66%. But notice that we didn't even really need to do that last step because what we wanted in the equation was that 1 plus R, and we solved that, right? That 1 plus R is equal to 1.0366. So I'm going to kind of go over here and say, now we know that our equation is Pn equals 45 times 1.0366 to any number of months, right? And now n can really be a true variable where we can just enter the number of months. And then the final question about this is saying, well, what's the value after 2 years, which is equivalent to 24 months? And we wrote this equation sort of in terms of months. What is going on? My pen all of a sudden is like writing one. Oh no. What if how can I stop? What if I switch colors? Maybe it'll do it. Okay, that stopped it. Let's get rid of all that stuff. There we go. So plugging 24 in right there, this becomes P of 24 equals 45 times 1.0366 to the power of 24. Now, this is why rounding is so important in this, or rounding to more places than usual. It's because something to the 24th power, that's a lot of multiplication. So I'm going to enter that exactly as we see it on the screen. 45 times 1.0366 to the power of 24. And that gives me 106.6305. And I'm just going to check the answer real quick. You're not going to be able to see it, but yeah, 106.63 is what they were expecting. So that would work. But yeah, notice, I just want to point out that we rounded at several places. We rounded this number. When I took the 8th root, I rounded that number. And then, so this number, when I entered this, it was rounded twice. So every time we round, we're changing the number slightly, which is why, and then bringing to the 24th power, that really just balloons numbers. So those, even though a 4th decimal place might not be a lot, first of all, this is measured in thousands. So that's really like 1,000 times bigger than what we see. It's actually 106,000 users. So those little differences can mean a lot. But anyway, I hope that got you there. And thanks for watching.